Welcome dear students. So today we are going to start a new topic, and today's topic is going to be entirely based on the formula. Okay, so yesterday we learned about derivatives, right? Okay, and from there only actually all these formula have been derived. You can easily find the proofs of this in your textbook also using the first principle. That means the derivative of x to the power n will be n x to the power n minus 1. All these are present in your textbook only. Okay, so without wasting much time, let's see each formula. Okay, so the derivative or the differentiation of algebraic functions. Now in algebraic functions we have functions like x to the power n. Okay, so the derivative of x to the power n will be this much, and if in this case the derivative of, so you might be wondering what is dx and all. Okay, so sometimes most of the people say that this is dx. Okay, they read this as ddx of x to the power n, or else if you want to read this as d by dx, that's also fine, but the only thing is formula should be correct. Okay, so I have the habit of reading this as d by dx, so I'll read that way only. So d by dx of x to the power n is this much. D by dx of x. Now here the power is 1, isn't it? X to the power 1. So put the value of n to be 1 here. So it becomes 1 into x to the power 1 minus 1. So x to the power 1 minus 1 is 0, right? X to the power 0 is always 1. So 1 into 1 becomes 1. Easy. Okay. And you need to remember one thing is the derivative of constant is always 0. Okay. So these kind of functions are known as algebraic functions. Now let's see the derivative of trigonometric functions. The derivative of sin x will be cos x. The derivative of cos x will be minus sin x. For tan x it will be sec square x. For cosec x it will be this much. For sec x it will be this much, and for cot x it will be this much. Okay, see, how much ever problems you practice, that will give you the confidence for remembering these formula. Okay, so one small thing I want to say here. See, cos start with c, isn't it? Cosec also starts with c. Cot also starts with c. And you see, for them the derivative is all negative. Okay, so this is one small tips for you to remember this formula. So if it starts with c, then your answer should be negative. That you should keep in mind. Next is exponential function. So for a to the power x it will be this much. Now for e to the power x, this is a special case from here. Okay, this case is derived from this, and this will turn out to be e to the power x itself. Okay, so the derivative of this will remain as it is. Now for logarithmic function, now remember here the base of this log is e. Okay, so if it is e, then your answer will be 1 by x. Okay, fine. Now actually this part is there in your class 12. Okay, they don't mention this in class 11, but since we are writing down the formula, let's learn this also. Okay, so the formula here is also similar. For sine inverse x, if it is this much, for cos inverse x, it's going to be negative of this. It's very easy to remember. Okay, so it's just negative. For tan inverse it will be 1 by this much. Okay, now for cot inverse it's going to be just negative of tan inverse. Okay, now for cosec inverse it will be negative of this, and for sec inverse it's going to be just opposite of that, that is it's going to be positive. Now here again, whatever starts with c, all of them will have negative sign. Alright, so this is all about the formula. Now let's see few fundamental rules of differentiation. Okay, so for example, if you have sum or difference plus or minus of two functions, that is f and g, then the derivative rule says that you can leave your plus and minus. First find the derivative of f, find the derivative of g, and add or subtract them. Okay, so this is the rule. You need to remember this. Now for multiplication, if there is a multiplication of two functions fx and gx, then the rule is this one. That means first keep fx aside, differentiate g, put plus sign. Now if you have differentiated g, next time you keep it as it is and differentiate the one which is not differentiated, that is fx. Okay, so you will differentiate fx in the next time. Third one, very important, and most of the students get confused with this, but what to do, you need to memorize it. Okay, so whole divided by is there, so basically this is in the denominator. I have written in this way because I don't have much space here. So in the denominator I have written gx whole square, that is whatever is in the denominator that will be squared here. Now in the numerator we are just going to have opposite of this. Okay, first we will differentiate fx. Okay, gx will be kept as it is. This is plus here, this becomes minus here. Okay, now this time first you differentiated fx, isn't it? That is the numerator, so that numerator will be kept as it is, and next time you will differentiate the denominator. So these are the formula or the rules that you need to remember in order to solve problems on differentiation. So you may pause the video and note down the formula. So dear students, my first question is on the board. So your question says differentiate the following with respect to y. Okay, so this is the given function, right? So fx is given to be this much, or if you want to write this to be y, that's also fine. Okay, so let y is equal to, so you will write let y is equal to this much. Okay, now, or if you want to write fx, that's also fine. Now below this you have to write differentiating both sides with respect to x. Okay, so differentiating both sides with respect to x. Now suppose if you write fx here, then the differentiation of fx will be f dash of x, isn't it? Yes, so that also can be done. Or if you don't want to write fx, then you write y here, isn't it? So if you write y here, then the differentiation of y will be, remember, dy by dx. Okay, now why x? Because you are differentiating with respect to x. Now if you write t out here, if you write t, then you have to write t here. Okay, so basically t is the variable. Okay, and what is the variable here? You see that x is the variable, so that's why you have to differentiate with respect to x only. Okay, so when you differentiate with respect to x, you have to write dy by dx. Okay, so if you see here, there are three different things, isn't it? Yes, three different terms. So here what we do is we will differentiate each term. Okay, so that means it will become d by dx of x cube by 3. So this is the one term. Okay, next is, okay, so minus is there, so next is d by dx of 2 root x. Okay, now what am I doing here is, you saw fundamental rules, isn't it? So in the fundamental rule, if I go to the first fundamental rule, there it was this rule only. Instead of plus, if there is plus sign here, then you have to write plus. If there is minus sign here, you have to write minus. That rule is mentioned in the fundamental rule. Now here you see that there is plus, so that's why you have to write plus here, and you have to differentiate the last term, that is 5 by x square. Okay, since this is my first problem, we'll see, or rather we'll learn it slowly. Fine. Okay, so one more thing that I want to mention here is, mostly I would not have mentioned in your fundamental rule. You can add it. Okay, so in fundamental rule you can keep it as 4, so just write d by dx of kfx. Okay, so where k is constant, so this constant can be kept outside and it can be written as d by dx of fx. So you can add this also in your fundamental rule. Okay, so see here carefully, this 1 by 3 as a constant, isn't it? So if that 1 by 3 is present, that constant can be kept outside. So let me write 1 by 3 outside. So this becomes d by dx of what's left, x cube is left. Yes, okay, similarly this constant can be kept outside, so this becomes 2 d dx or d by dx of Okay, so root x is x to the power half, isn't it? Yes. Plus this 5 comes outside. So this is d by dx of 1 by x square. Now 1 by x square can be written as x to the power minus 2, isn't it? Okay, so in this way we get 1 by 3. Okay, so this is d by dx of x to the power n. So the formula says it is n, that is 3 x to the power n minus 1. Okay, n x to the power n minus 1, because n is 3. Similarly here minus 2, here n is half, so that's why it will become n x to the power n minus 1 plus 5 is there, so it will become n, that is minus 2 into x to the power n minus 1. I hope this step is clear to you. So the first formula, that is d by dx of x to the power n, is n x to the power n minus 1 is used here. Okay, so let's simplify. So 3 and 3, 2 and 2 gets cancelled. So this is how much? X to the power 3 minus 1 is x square, right? Okay, so minus, this is x to the power minus half, isn't it? Half minus 1 is minus half. Yes. So plus into minus is minus, this is 10 x to the power how much? Minus 3. Okay, so this can be ultimately written as x to the power 3 minus, so this minus is there, so it can be written as x to the power half, right? 1 by x to the power half can be written instead of this, but instead of x to the power half I am writing 1 by root over x. That is also fine. Similarly this becomes minus, so this is 10, this x cube goes to the denominator, becomes, I'm sorry, x to the power minus 3 from the numerator goes to the denominator and it becomes x to the power 3, that is x cube. So this is my, okay, this, I'm sorry, this is x square here. So this is my answer for this particular question. So pause the video and note it down. Okay, so this is my second question. So again, let this be my y. Okay, so let y equals to this one. Now if you see here, this is actually fx for me and this is my gx for me. Okay, so actually it's fx into gx, isn't it? And you are finding derivative of fx into gx, right? So differentiating both sides with respect to x, in the left hand side you get dy by dx. In the right hand side you have fx into gx, right? So second fundamental rule says first keep fx, okay? So fx will be kept front, that is x plus 1 by x, and we need to differentiate gx, right? So let's differentiate gx, that is root x plus 1 by root x. Okay, now you have to put plus sign as per the rule. Now this will be kept as it is, root x plus 1 by root x will be kept as it is. Now we need to differentiate fx, that is this one. So we have x plus 1 by x. So this is the rule. Okay, now as you know, let me keep it as it is for now. Now you know that this is like my fx now. So this is my fx plus gx. Now again you can do one thing. So you can write this as d by dx of, okay, so this is root x is x to the power half plus d by dx of 1 by root x. So what is 1 by root x actually? It is x to the power minus half, isn't it? Yes. So this can be written this much. Similarly the same thing will be done here. So this is root x plus 1 by root x. Okay, so again d by dx of x plus d by dx of 1 by x, that is x to the power minus 1. Okay, now let's simplify. So we have x plus 1 by x here. So differentiation of x to the power half will be n into x to the power n minus 1. Same thing goes here. So n, that is this comes front because, okay, because minus half, isn't it? So plus into minus half is minus half. So this is n x to the power n minus 1. Okay, so this is differentiation of this part. Similarly we'll do the same with this as well. So this is root x plus 1 by root x. So differentiation of x, algebraic functions, go to the first formula, second formula in fact. So it will be 1. So this is again see here carefully. Okay, n x to the power n minus 1. Yes, okay, fine. Let's simplify this again. So x plus 1 by x is there. So this is how much? So this is half. So in fact this is this much, I guess. Okay, so similarly this is, if you simplify this is x to the power minus 3 by 2. When it goes to the denominator, it becomes 2x root x. Now you just simplify this and check, you will get this much. Okay, plus root x plus 1 by root x. Okay, now how much is this? This is 1 minus, okay, plus into minus is minus, so x to the power minus 2 can be written as 1 by x square. Yes, okay. So if you want to keep your answer this much, that's also fine, or if you want to take something common from here, that is also possible. So we have x plus 1 by x here. Yes, what is common here? 1 by 2 root x. Yes, so if I keep that common, that is 1 by 2 root x. Okay, so instead of that, you can do one thing. So keep 2 root x here. So this becomes equal to, so here what will be left? Here 1 will be left, and here you will get this much. Yes, so plus, similarly this becomes root x plus 1 by root x. So this is 1 minus 1 by x squared. So this will be my answer for this particular question. So pause the video and note it down. Okay, so this is my second question. So again, let this be my y. Okay, so let y equals to this one. Now if you see here, this is actually fx for me and this is my gx for me. Okay, so actually it's fx into gx, isn't it? And you are finding derivative of fx into gx, right? So differentiating both sides with respect to x, in the left hand side you get dy by dx. In the right hand side you have fx into gx, right? So second fundamental rule says first keep fx, okay? So fx will be kept front, that is x plus 1 by x, and we need to differentiate gx, right? So let's differentiate gx, that is root x plus 1 by root x. Okay, now you have to put plus sign as per the rule. Now this will be kept as it is, root x plus 1 by root x will be kept as it is. Now we need to differentiate fx, that is this one. So we have x plus 1 by x. So this is the rule. Okay, now as you know, let me keep it as it is for now. Now you know that this is like my fx now. So this is my fx plus gx. Now again you can do one thing. So you can write this as d by dx of, okay, so this is root x is x to the power half plus d by dx of 1 by root x. So what is 1 by root x actually? It is x to the power minus half, isn't it? Yes, so this can be written this much. Similarly, the same thing will be done here. So this is root x plus 1 by root x. Okay, so again d by dx of x plus d by dx of 1 by x, that is x to the power minus 1. Okay, now let's simplify. So we have x plus 1 by x here. So differentiation of x to the power half will be n into x to the power n minus 1. Same thing goes here. So n, that is this comes front because, okay, because minus half, isn't it? So plus into minus half is minus half. So this is n x to the power n minus 1. Okay, so this is differentiation of this part. Similarly, we'll do the same with this as well. So this is root x plus 1 by root x. So differentiation of x, algebraic functions, go to that first formula, second formula in fact. So it will be 1. So this is again, see here carefully, okay, n x to the power n minus 1. Yes, okay, fine. Let's simplify this again. So x plus 1 by x is there. So this is how much? So this is half. So in fact this is this much, I guess. Okay, so similarly this is, if you simplify this is x to the power minus 3 by 2. When it goes to the denominator, it becomes 2x root x. Now you just simplify this and check, you will get this much. Okay, plus root x plus 1 by root x. Okay, now how much is this? This is 1 minus, okay, plus into minus is minus, so x to the power minus 2 can be written as 1 by x square. Yes. Okay, so if you want to keep your answer this much, that's also fine, or if you want to take something common from here, that is also possible. So we have x plus 1 by x here. Yes, what is common here? 1 by 2 root x. Yes, so if I keep that common, that is 1 by 2 root x. Okay, so instead of that, you can do one thing. So keep 2 root x here, so this becomes equal to, so here what will be left? Here 1 will be left, and here you will get this much. Yes, so plus, similarly this becomes root x plus 1 by root x, so this is 1 minus 1 by x square. So this will be my answer for this particular question. So pause the video and note it down. Now this is my third question. So again, let me take this to be y, differentiating both sides with respect to x. So this is dy by dx in the left hand side. In the right hand side, isn't it fx by gx? Now the differentiation of fx by gx will be, in the denominator we have gx square, right? So we'll keep that later. Numerator, let's see the numerator. So in the numerator we have first gx, then what is gx actually? Denominator. So denominator will be kept first, and we need to differentiate the numerator, that is fx. And fx is how much? This is a cos x plus b sin x plus c. Yes, next you have to write minus this time. Now this will be kept as it is, so let me keep it as it is. So a cos x plus b sin x plus c, and now we need to differentiate fx. So d by dx of fx. What is fx? I'm sorry, gx. This is my fx. Now we need to write gx. What is gx? Gx is sin x for me. Okay, so this is my numerator. Divided by, there is something, so divided by we have denominator square, that is square of sin x is sin square x. Alright, now let's open up the bracket. Let's differentiate, in fact. So we have first is sin x. Okay, so differentiation of this one. Okay, so this becomes, so a is constant, will be kept outside, so we need to differentiate only cos x. So differentiation of cos x, plus similarly b will be kept outside, so we need to differentiate only sin x. So differentiation of sin x, and you know what is the differentiation of c? Okay, so for now let's write it. So differentiation of c, okay, minus we have, this will be kept as it is, so a cos x plus b sin x plus c, and you know what is differentiation of sin x? It is cos x, right? So that's why I've written cos x here, divided by, we have got sin square x also. Okay, fine. Now let's simplify. We have sin x. Okay, so a is there, differentiation of cos x is minus sin x, so that's why it will become minus a sin x. Okay, similarly this is differentiation of sin x is cos x, so that's why this will become b cos x. Now b cos x, plus what is differentiation of c? C is a constant, so that's why it will be 0, minus, so this will be, okay, we can in fact multiply here, so this becomes a cos square x plus b sin x cos x plus c cos x, right? So this is my numerator, and we have got in the denominator sin square x as well, right? Okay, now let's open up the bracket. So we have minus a sine square x plus b sine x cos x. Yes, so 0 is gone. So this is minus a cos square x, plus into minus is minus b sine x cos x, minus into plus is minus c cos x. Okay, so this is the simplification of numerator. So we have got divided by sine square x as well, remember. So we have got this plus, this minus, they will get cancelled. So you see that minus a is common here, isn't it? So if I keep minus a common here, then we get from here sine square x, and from here we get plus cos square x, and we are left with minus c cos x, and we have divided by sine square x. Now how much is this? This 1 into a is a, right? So in fact you can take minus common. Okay, so let me keep minus common. So in the numerator we have a plus, now this becomes plus because minus is kept outside. So we have c cos x divided by sine square x. Okay, so this is my answer. So you may pause the video and note it down. So in the earlier question, there's one more technique. Okay, so let me take this question as an example. Okay, so you can compare this question with the earlier question. So this is your y. So basically in earlier question what you did, you used f by g, right? So I just showed you that because I wanted you to get familiarized with the technique. Now here I'm not going to do that. You know why? Because here I can simplify this. So if you are able to simplify the given expression, that will be better for you. Okay, so for example, here what am I going to do is, let's multiply the numerator first. So x into x cube is x to the power 4. So x into 1 is so plus x. So this becomes minus 2x cube minus 2. In the numerator and in the denominator we have x squared. Okay, so now again this is f by g, right? So this can be instead written as x to the power 4 by x square. We have got plus x by x square, x by x square is there, minus 2x cube by x square minus 2 by x square. Okay, so now our work is becoming easy, isn't it? Now this can be written as, this is x square. Yes, so this is x square. So this is 1 by x, that is x to the power minus 1. Okay, this is 2x, right? So minus 2x minus this is 2x to the power minus 2. Now your work is very easy. Now differentiating both sides with respect to y, you will get dy by dx is equal to derivative of the first one, that is x square, plus is there. Next is derivative of second one, that is x to the power minus 1. Next we have minus 2 will be kept outside. So derivative of x, and we have minus 2 outside, that is the derivative of only x to the power minus 2. Okay, now you can simplify, isn't it? So this is x square is x to the power n. So it will be 2x to the power n minus 1 plus n into x to the power n minus 1, minus 2 is there. So differentiation of x is always 1. Yes, minus 2 is there. So x to the power n. So it is n x to the power n minus 1. Okay. So actually how much is this? This 2 x to the power 1, that is x. So plus into minus is minus x to the power minus 2 is 1 by x square. Yes, minus 2 into 1 is 2. Okay, so minus into minus is plus 4 x to the power minus 3 can be written as 4 by x cube, isn't it? So your answer for this particular question will turn out to be this much. So you may pause the video and note it down. Now before going into this problem, I have mentioned two very important formula and very easy to remember. Okay, especially the first one. See here, this can be written as, so in the base we have got a. Okay, so base is lying below, isn't it? So that's why I'm writing this in the denominator. Okay, so log a is written in the denominator, b is situated at the upper position, so that's why I've kept log b in the numerator. So log b, log a. Now you can introduce a new base c, but of your choice. Okay, so this is very important formula. Next is this formula. Okay, now you have to learn it by heart. Fine, so these two formula are there. Now see, let's see few examples where these formula can be used. Okay, fine. So this is my exponential function, isn't it? So let me call this to be y. Okay, now see here, this, forget about this e, you have x log a, isn't it? Now x log a can be written as log a to the power x, isn't it? Yes, so we have x log a is equals to log a to the power x, and remember base is always e. Okay, generally what happens is, whenever you see log x, they say that the base is 10, but in calculus, if there is no mention of any base, then you have to think that the base is always e. That means since we are doing calculus and since there is no base mentioned, that means the base is e here. Okay, so this is actually e to the power. Okay, so instead of this I have written this. All right, same thing will be done here also. So e to the power log x to the power a, right, plus we have e to the power log a to the power a. I hope you are clear with this formula, because you know that there is one more formula. Let me write it. So the formula says log a to the power b is b log a. Okay, so the power comes front. Same thing is happening. See here, power comes front becomes this, power comes front becomes this, power comes front becomes this. Okay, now look at the formula number 2. Look at this. This is e, this is e. Yes, in this case, see, base is e, no? For these case, e is the base, so that's why this is matching with this, isn't it? So how much ever is here with log, we have that value, isn't it? So here we have with log a to the power x, so that's why this entire thing is actually a to the power x. Similarly, how much is this? This is x to the power a, and this is a to the power a. So this is the value of y. Now we'll write differentiating both sides with respect to x. The variable is x, remember. Now a is a constant, all right, so we get differentiation of a to the power x, plus we have differentiation of x to the power a, plus we have differentiation of a to the power a. Now look here carefully. We have, okay, so this, the differentiation of a to the power x, how much is this? This is a to the power x log a with base e, or if you want to remove this base, that's also fine. Since we are doing calculator, you must assume that the base is e. Okay, so this is x to the power n actually, right? So that's why this can be written as n x to the power n minus 1. Okay, plus now a to the power a is a constant, so that's why a to the power a is also constant, so that's why this will be 0. So what is your answer here? So your answer turns out to be a to the power x log a plus a x to the power a minus 1. Please do not get confused with this and this. So you may pause the video and note it down. Now let's have this problem. Now again, you remember, you see that there is logarithm out here, so you have to go for logarithmic. Okay, so differentiation of logarithmic function. You know that the formula is d by dx of log x is equal to 1 by x. This is the formula available. Now what is the base here? The base is e. If I differentiate both sides, what will be the problem is we don't have e as the base here. So let's make e as the base. For that we need to make use of this, because here you see that c is the new base that I have introduced, isn't it? So the same thing I am doing here also. So we have, okay, so this can be written as log, so x is on top, so that's why it will be kept in the numerator. 3 is in the below, right? So that's why this will be kept in the denominator. Now I'll introduce a new base, that is e. Okay, one more formula you can notice, log ab can be written as 1 by the base, and this number will be changed. So b will become the base and a will become the number. Okay, so this is also one formula. So this is plus 3 log ex plus 2 tan x. Okay, so that's what we have got now. Now let's differentiate both sides with respect to x. Okay, so dy by dx. Now you see that this part is constant because we don't have any x here, so that's why it will be kept outside. So 1 by log e3 here, and we have differentiation of what? Only log x. So log x to the base e plus 3 is a constant kept outside, so d by dx of log x to the base e plus 2 differentiation of tan x. Okay, fine. Now compare with this, we have this equal to log, now 3 will go to the base and this e will remain here. Okay, so this becomes 1 by x as per the formula. So we have plus 3 into, here also this is 1 by x plus 2 differentiation of tan x is sec square x, isn't it? So that's why your answer turns out to be, so if I take 1 by x common, then you will get log e to the base 3 plus 3 here plus 2 sec square x. So this will be your answer for this particular question. Pause the video and note it down. So let me take this question now. So question says, if for fx equals to this one, lambda x squared plus mu x plus 12, f dash of 4 is 15 and f dash of 2 is 11, then you are expected to find the value of lambda and mu. Okay, so given is this, and what do you mean by f dash? F dash represents the derivative. Okay, so if I call this as equation 1, that is this one, you will write, okay, so given this, call it equation 1. Then differentiating 1, that is this, with respect to x, because the variable is x out here, so that's why you have to write x. Then this fx becomes f dash of x. Okay, now lambda is a constant, will be kept outside, so we need to differentiate only x square, plus mu is a constant, so we will differentiate only x, and at last we don't have any x here, so it is actually differentiation or the derivative of 12. Okay, so this is, how much is this? The differentiation of x square is 2x, so that's why this will be 2x lambda plus differentiation of x is 1, so that's why this will be mu, and the differentiation of this is equal to 0. No need to write 0, isn't it? So this is my f dash of x. Let me call this as equation number 2. Okay, so using 2, okay, so using 2, let's find what is f dash of 4. Okay, so f dash of 4 means instead of x I have written 4, so that's why here also I have to write instead of x 4. So this becomes 2 into x is 4 into lambda is there plus mu. Now do you know what is the value of f dash of 4? It is given to be 15, right? So this 15 equals to this 8 lambda plus mu, and in other way this becomes 8 lambda plus mu is 15. Let me call this to be equation number 3. Okay, also using 2 only, let's find what is f dash of 2. So f dash of 2 will be equals to, instead of x we have got 2 now, so this becomes 2 into lambda plus mu, and f dash of 2 is given to be 11. So 11 turns out to be 4 lambda plus mu, or in other way this is 4 lambda plus mu is equal to 11. Let me call this to be equation 4. Okay, now you want to find the value of lambda and mu from 3 and 4. They are simultaneous equation. It's very easy to find. Okay, so you can find by your own way. I'm going to find it in another way. I'm going to subtract 4 from 3. Okay, so subtracting 4 from 3. So let's see how much do we get. So let me write first 3. So 8 lambda plus mu is equal to 15, and let me write equation number 4, that is 4 lambda plus mu is equal to 11. So you are subtracting this 4 from 3. So when you subtract, the sign will reverse, isn't it? So this is plus mu, this is minus mu, equal to 15 minus 11 is 14. Yes, 8 lambda minus 4 lambda becomes 4 lambda. So from here lambda turns out to be 14 by 4, that is 7 by 2. Okay, so using equation, let me use equation number 3. Okay, so let me use equation 3. So using 3, we have 8 lambda is 7 by 2 plus mu is equal to 15. Okay, so this and this gets cancelled. So this is 28 plus mu is equals to 15. So mu turns out to be 15 minus 28, which is minus 13. So therefore lambda is 7 by 2 and mu is minus 13. So these are my answer for this particular question. So you may pause the video and note it down. Now let's see this problem. So question says y is given to be this much, you need to prove this. Okay, so here in the proof you see that there is dy by dx, right? So let's quickly find dy by dx. Okay, let me call this to be equation number 1. Let's differentiate 1. So differentiating 1 with respect to the variable is x. Remember, a is a constant. Okay, so with respect to x, then you will get dy by dx will be equals to, so this is actually, you know, dy by dx of square root of x by square root of a. Yes, plus similarly this is dy by dx of square root of a by square root of x. This means this, isn't it? So let me take out the constants first. So we see that the constant here is 1 by square root of a, and you are differentiating x, actually x to the power half. Yes, so differentiation of x to the power half, root over a is constant, so basically you are differentiating here 1 by root x, which is x to the power minus half. Okay, now the rest of the thing is very simple. So this becomes n x to the power n minus 1 plus root over a n x to the power n minus 1. Yes, okay, so this becomes 1 by 2 root a x to the power minus half is square root of x, right? Plus, I'm sorry, plus into minus is minus. So we have got in the numerator, we will get root over a. This 2 is in the denominator. This is x to the power minus 3 by 2. And you know that x to the power minus 3 by 2 can be written as x root over x in the denominator. Yes. So this is my value for dy by dx. Now, let's see what do we have in the left hand side. So in the left hand side, we have 2xy dy by dx. Let's simplify this. So we have 2x, and what is y? Y is this entire thing. So let me write this as root over x by root over a plus root over a by root over x. So this is my value for y. Now what is dy by dx? Dy by dx is this one. Yes. So is there anything common that you can see here? Okay, let's keep it here this much only. So we have 1 by 2 1 by, so we have square root of a square root of x minus square root of a minus divided by 2x root x. Okay, now you see that this 2, okay, so let's take out 2 common. So if I take out 2 common, okay, let me do it in the next step. So let me multiply with this 2x here. Okay, so let me keep it here this much only. So root x by root a plus root a by root x. This will be kept as it is. 2x will multiply with this. So this becomes 2x by 2 root over a root over x minus, we have 2x into this is 2x root over a by 2x root over a. Okay, so 2 and 2 gets cancelled, 2x and 2x gets cancelled. Okay, so this x and this square root of x, you know that this x can be written as square root of x square. So square root of x square is in the numerator and denominator contains root x. So this and 1 gets cancelled. So in the numerator we have only root over x. So that's why this can be written as root over x by root over a plus root over a by root over x. And this is, okay, so in the numerator we have got root over x, in the denominator we have root over a minus we have root over a by, I'm sorry, this is x, right? So this is x. So in the denominator we have this. Now if you see here, this is a plus b, a minus b, which is a square minus b square, right? So this is a square minus b square means root x by root a square minus root a by root x square, and this turns out to be x by a minus a by x. So that's what we need to prove, right? So you may pause the video and note it down. Now dear students, we'll learn about the geometrical interpretation of derivative at a point. Okay, so for that let me take xy coordinate system, and before that you know the definition of derivative, that this limit should exist, isn't it, at point C, remember? So at point C, if this limit exists, then the derivative, that is f dash of x, is existing, right? And there's one more definition, that is left hand derivative and right hand derivative. In fact, if these two are equal, then only we say that this limit exists. Yes, so this was the thing that we learned in the earlier class. Okay, so in today's class, if we want to understand geometrical interpretation of derivative at a point, all these three things should be known to us. So for that, there should be one function fx, isn't it? So let me draw a random function here. Okay, so let me draw a random function. So this is my y equals to fx. Okay, and you want to find derivative at point C. So let me take that point C to be somewhere over here. Okay, so if this is my C, look here carefully. So if you want to find the coordinate of this, okay, so C means from here to here is C. Okay, so if the value of x is C, then this is the value of y. Yes, because in our coordinate what do we have? X comma y. So the value of x is C. Now the value of y will be how much? Y equals to f of x. And what is the value of x? X is C. That means the value of y, that means this height is how much? F of C. I hope this thing is clear to you. So let me draw a horizontal line here. So basically this height is my FC. Okay, now what am I going to do is, I'm going to introduce a very small h. As I said, h is a very small positive quantity, right? Very small. Okay, so that very small thing cannot be shown in this diagram. So let me choose that small h to be this much. This is my h. Okay, so if this is my h, let me choose one more h here. So see here carefully, from here to here is h, and from here to here is also h. So if this is my h and from here to here is c, then what will be this? This will be c minus h, isn't it? Till here is c minus h, from here to here is h, c minus h plus h will give you c. Similarly, this will be your c plus h. Remember, from here to here is c, from here to here is h, so from here to here it's going to be c plus h. I hope this thing is clear to you. Now let's plot the corresponding value. So you know that when it is c, this point is, or this height is fc. Now this point is c minus h, so that's why this height, that is this horizontal line, so let me call this height. So this height is going to be f of c minus h. Okay, fine. Similarly, this height, so let me draw a perpendicular from here. So this horizontal line, let me draw it first. So basically this height, okay, so this height from here to here is going to be f of c plus h. I hope the diagram is clear to you. Okay, now let me plot or give name out here. So let me call this point to be point P. Let me call this point to be Q, and let me call this point to be R. Okay, now see here carefully. If I ask you what is the coordinate of P, you said that the coordinate of P is, first you have to write abscissa, yes, then the ordinate, that the y value is fc, yes or no? Now if I ask you what is the coordinate of Q, you say that this is c minus h, and what is the y value? This is f of c minus h, so f of c minus h. And similarly the coordinate of R will be c plus h comma f of c plus h. Okay, now let me join these two line. Okay, so you see that P and Q is there, so let me join this. Okay, so PQ is joined, so let me show it this way. Okay, so can you see a line over there, straight line joining P and Q? Yes. So if I ask you what is the slope of this, you have got the coordinate of this, you have got the coordinate of this, you have got x1 y1, you have got x2 y2, so you have to find the slope using the formula. Slope will be equals to y2 minus y1 divided by x2 minus x1, isn't it? Yes, so that's why. Okay, so let me write here. So slope of, okay, PR, line PR is going to be, so P and R, they are here, isn't it? Okay, so it is y2 minus y1. So let me call this to be x1 y1, let me call this to be x2 y2. So this becomes y2 minus y1, that is f of c plus h minus y1 is f of c divided by x2, that is c plus h minus x1, that is c. I hope this thing is clear to you. y2 minus y1, x2 minus x1. So this is the slope of line PR. Now similarly, let me join this line. Okay, so let me join P and Q and form a straight line PQ. So the slope of PQ, let me write it here. So slope of PQ will be equals to, so P is here, Q is here, call this as x1 y1, call this as x2 y2. So this becomes y2 minus y1, so y2 minus y1 divided by x2 minus x1, that is c minus h minus c. Okay, so the slope of PR is given by this and the slope of PQ is given by this formula. Now if you pay attention here, this looks like this, isn't it? I'm sorry, this one, right hand derivative, yes, and this looks like left hand derivative, right? Okay, so you know that as h goes very close to 0, it doesn't mean that this h is going towards 0. H is a distance, or I should say a width, yes, so that width is becoming very small. That means this h is becoming very small, or in other words, this q is going very close to p, right? when h goes to 0. That means if width becomes very small, it means that this q is going very close to p. And similarly, if this h goes close to c, or if h becomes 0, if h tends to 0, this means that this r is also going towards p. Okay, now in that case, so when h tends to 0, what happens is this q, p and r, they act like a single point or very close to each other. So suppose if q reaches here and r reaches here, then it becomes like when you join this line, or this line is there, no, this line and this line, they also come closer to each other. This line, that is PQ and PR, also comes closer to each other, and when h tends to 0, that is when all these 3 points come very close to each other, then this line acts like a tangent at point C, isn't it? Yes. So when h tends to 0, Q and R comes very close to P, and the line PQ and PR in fact acts like a single line, which is a tangent to the curve at y equals to fx. Okay, and this tangent is exactly at point C. Okay, and that time what happens? I said when h goes to 0, okay, when width is becoming 0, I said that left hand derivative and right hand derivative becomes equal to each other. And you know that left hand derivative is the slope of what? Line PQ. And right hand derivative is the slope of line PR. And when h goes to 0, PQ and PR, in fact, they are becoming a single line, that is a tangent. That means these two slopes are also becoming equal. Now, if these two slopes become equal, this slope will be the slope of which line? This slope will be the slope of this tangent, isn't it? That means this, they are becoming equal, means this value, yes, if they become equal, that becomes this value, isn't it? So this value is what? It's a slope of which line? Of the tangent. So that means the geometrical interpretation of derivative at a point says that the derivative of point at point C, derivative of function at a point C will give you the slope of the tangent drawn at the point C. That's all you need to remember. Okay, so basically you say dy by dx or you say f dash of x, all this will give you the slope of the tangent. That's all you need to remember. So you may pause the video and note down the very important points. So let's have the last question for the day. So question says, find the slope of the tangent to the curve this at x equals to 1. Now this is entirely based on your concept of geometrical interpretation. Now given is fx is equals to 2x to the power 6 plus x to the power 4 minus 1. And you want to find the slope of the tangent to this curve at point 1, x equals to 1. Yes. So you know that the slope of the tangent is given by its derivative. Yes. So that's why I'm finding the derivative, or you can write differentiation or differentiating both sides with respect to what is the variable? The variable here is x. So that's why this becomes f dash of x here, and this becomes 2 differentiation or the derivative of x to the power 6 plus derivative of x to the power 4 minus derivative of x1. So this becomes x to the power n. So this becomes 12. So actually 6x to the power 5, but 6 into 2 is 12. So that's why it will be 12x to the power 5 plus this becomes 4x cube minus 0, because this is constant. So that's why, therefore, you are asked to find the slope of the tangent at x equals to 1. So therefore, slope of the tangent is equal to, you know that slope of the tangent is given by f dash. Yes, but at which point you are asked to find at x equals to 1. So instead of x I have written 1. So we have this equal to 12. So f dash is this much. So instead of x, I am going to substitute 1. So that's why this will be 12 into 1 to the power 5 plus 4 into 1 cube. So this is 12 plus 4, and this turns out to be 16. So the slope of the tangent will be equals to 16. So you may pause the video and note it down.